Grade 7 learners, welcome sa isa namang episode na punong-puno ng kaalaman. Maraming matutunan, mundo ng numbers ating niyang pag-uusapan. Kaya't ano pang hinihintay nyo? Tara na! Halina't MATH-TUTO! Are you ready for a fun-filled discussion? By the way, I am your math teacher for today. I'm Mr. Floro Palomeras Jr. Get your learner's packet, answer sheet and ballpen, and stay tuned to another exciting Grade 7 mathematics lesson only here at HALINA'T MATH-TUTO sa Dasmariñas North National High School.
Last week, we talked about the rational numbers. We learned how to express rational numbers from fraction form to decimal form, and vice versa. Also, we learned how to perform operations on rational numbers. On week 6 of quarter 1, we talk about square roots, but we'll focus on estimating the square root of a number on the nearest hundreds and plotting irrational numbers. By the end of the lesson, the students are expected to estimate the square root of a number to the nearest hundreds. Then, illustrate and graph the approximate location of irrational numbers on the number line. What if you are given a task to estimate the square root of a number which is not a perfect square? What will you do? There you go. I know that you have now question in mind. At the same time, excited to learn on estimating the square root of a number to the nearest hundred. With that, let's get started. When finding the square root of a number on the calculator, you will notice that the answer is irrational numbers. But for the number which is not a perfect square, you will see several digits after the decimal point. This means that the answer is irrational numbers. We cannot express to the fraction forms. To determine the approximate value of the square root of a number that is not a perfect square, a series of estimation is made. Here are the following steps that will guide you how. Step 1. Find the perfect square less than and greater than the number which are closest to the given number. Step 2. Make an educated guess to one decimal place and try it. And step 3. Decide which closer. Let's take a look at the sample. Estimate the square root of a number to the nearest hundred. First example, square root of 2. We know 2 is not a perfect square. Now, what are we going to do? Let us estimate the square root of 2 by the following steps. Step 1. Find the perfect square less than and greater than the number which are closest to the given numbers. The perfect square closest to the given number are 1 and 4. The square root of 2 is less than the square root of 4 but greater than square root of 1. Since the square root of 1 is 1 and the square root of 4 is 2, we can say that the square root must be between 1 and 4. On step 2, make an educated guess to one decimal place and try it. 1 is 1 unit from 2, while 4 is 2 units from 2. From here, we know 2 is closer to 1 than to 4. So, the square root of 2 must be closer to 1 than to 4. Based from this step, we can say that the decimal should be less than 0.5. Now, let's try 1.4. By getting the square, we will multiply 1.4 by itself. That is 1.4 times 1.4. Result of multiplying 1.4 by itself shows 1.96 as the answer. 1.96 is still less than 2. This time, let's try 1.5. 1.5 squared is 2.95. That is more than 2. 2 should be between 1.96 and 2.95. Therefore, square root of 2 must be between 1.96 and 2.95. You get that? Moving on to the third step, decide which one is closer. 2 is closer to 1.96 than 2.95. So, the square root of 2 must be closer to 1.96 than 2.95. For the hundredths decimal place, we can try 1.41, 1.42, 1.43, 1.44, and 1.45. Since the value is closer to 1.96, if we square 1.41, the answer is 1.9881. For the square of 1.42, the answer is 2.0164. For the square of 1.43, the answer is 2.0049. Squaring of 1.44, the answer is 2.0736. Lastly, 1.45 squared, the answer is 2.1025. Which among the results is closer to the value of 2? That's right, 1.9881. We know by squaring 1.41, we will obtain the answer is 1.9881. Hence, estimated value of the square root of 2 in the nearest hundred is 1.44. Here is another example. Let us estimate the square root of 73 to the nearest hundredth. Step 1. The perfect square closest to 73 are 64 and 81. The square root of 64 is 8, while the square root of 81 is 9. Therefore, the square root of 73 must be between 8 and 9. Step 2. If we measure the distance of 73 from 64 on the number line, that would be 9 units, while the distance of 73 from 81 is 8 units. Since 73 is almost at the middle of 64 and 81, we must consider the decimal point probably is 0.5. This time, let's try 8.5, 8.6, and 8.7. 8.5 squared is 72.25. 8.6 squared is 73.96. And the square root of 8.7 is 75.69. Now, the value of 73 is between 72.25 and 73.96. So, the square root of 73 must be between 8.5 and 8.6. Step 3, we know that the value of 73 is closer to 72.25 than 73.96. So, the square root of 73 must be closer to 8.5. Let us try 8.51, 8.52, 8.53, and 8.54. The square of 8.51 is 72.4201. The square of 8.52 is 72.5904. 8.53 squared is 72.7609. And 8.54 when squared is 72.9316. From the obtained result, which has closest value to 73? Very good. That is 72.9316. How we obtain that? By squaring the number of 8.54. Thus, the square root of 73 when estimated to the nearest hundred is 8.54. Now, let's find out on how to plot irrational numbers on a number line. But first, what is irrational numbers? These are the numbers which cannot be represented as a simple fraction. Therefore, decimal form are non-repeating and non-terminating. Some example of these are: number 1, square root of 2. Number 2, square root of 10. And number 3, 5. If we are going to plot an irrational numbers on a number line, we are going to estimate first the square root of the given irrational numbers by following these steps. Step 1. Determine which two consecutive integers thus the square root of the given will likely fall. Step 2. Determine which of the two integers is closer to the square root of the given number. Step 3. On the number line, locate the two integers, then plot the point. Let's have an example. Locate and plot the square root of 3 on a number line. Let me show you how by doing this step. Step 1. Determine to which two consecutive integers does the square root of the given will likely fall. 3 is between the perfect square of 1 and 4. The square root of 1 is 1. The square root of 4 is 2. So the square root of 3 would likely fall between 1 and 2. Step 2. Determine which of the two integers is closer to the square root of the given numbers. 3 is closer to 4 than to 1. Since the square root of 3 is closer to 2, therefore, estimated value of the square root of the 3 in the nearest tens is 1.6, 1.7, 1.8, and 1.9. If we square this number, 3 will be fall from 2.89 and 3.24. So, the square root must be between 1.7 and 1.8. 3 is closer to 1.7 than to 1.8. It could be 1.71, 1.72, 1.73, and 1.74. 3 is closest to the square of 1.73. Step 3. On the number line, locate the two integers, then plot the point. Let us locate 1 and 2 on the number line. The square root of 3 is between 1 and 2. And we know that it should be closer to 2. Therefore, the square root of 3 should be closer to 2.
Since everything is clear, we will now start answering the learning task for the week. Don't forget to like, share, and subscribe in our YouTube channel so you'll be updated in our latest video upload. At ayun na nga, natapos na natin ang ating talakayan. Hanggang sa sunod na linggo, dito lang yan sa programa ng punong-puno ng kaalaman. Maraming mga tunan. Mundo ng numbers, ating niyang pag-uusapan. Dito lang yan sa HALINA'T MATH-TUTO sa Dasmariñas North National High School.